Hello students, in today's class I am going to discuss harmonic oscillator potential. So if particle is doing motion in a harmonic oscillator potential, what are its energy values and eigenstates? So harmonic oscillator potential is very important in physics because almost all kind of potentials can be approximated by harmonic oscillator potential near x is equal to 0. So let us go for uh, calculating the eigenstate and eigenvalues for the particle under harmonic oscillator potential. So we can write the Hamiltonian as p square upon 2m plus half kx square or m omega square x square x cap square. Now harmonic oscillator potential I can solve by two methods. One is called analytic method, which involves solving time independent Schrödinger equation. So solving this method involves solving time independent Schrödinger equation. And the second method is called operator method or algebraic method, or we call it operator method. This method uses ladder operators, which is also called annihilation and creation operator, or creation or annihilation operator. Also they call rising or lowering operators. So this second method is very easy and elegant. So I will use first this method, and then this analytical method we'll see later. So let us go for algebraic method. So I am introducing two operators, a dagger, or we call it a plus also, which is equal to, they are non-Hermitian operator, 2m h cut omega. I am writing it as a m omega x cap minus iota p. If plus is there, he'll come minus. And the second is called annihilation operator a, and this is, I write minus. Meaning will be clear soon. So 2m h cut omega m omega x plus iota p. Now let us calculate a dagger a. So if I calculate a dagger a, this will give me 2m h cut omega. If I multiply this one, this will give me m square omega square x cap square iota m omega x cap p cap. Similarly, minus iota p m omega p cap x cap, and then minus plus p cap square. So if I solve this one, this will give me 2m h cut omega. This is m square omega square x square, and you have p cap square, and this is nothing, this is the commutator. If I take iota omega m omega common, this become x commutator p. Now I can solve this one. This I can write as a I can send 1 by h cut here, and it will go here. This will give me half m omega square x cap square, and then you have a p square upon 2m, and similarly this is become iota m omega, and this is iota h cut upon 2m h cut omega. H cut omega cancel, m cancel, iota square is minus, so this become minus half, and this is your Hamiltonian. This is Hamiltonian. So I can write now that my a plus a, which I also say this is a number operator, a is equal to Hamiltonian upon h cut omega minus half. Okay, so this is, so my Hamiltonians now become n plus half h cut omega. Now my Hamiltonian and this number operator commutes. If I take commutator, because they are linear, they'll give me 0. That means now both should have a simultaneous eigenstate. So if I say when Hamiltonian operates here, you get En, eigenvalue is En. Similarly, for number operator, let us say the eigenvalue is n. Is n. So now if I use this one, so I can say my H operates on n, that is n plus 1 half h cut omega when operates on state n. Okay, this gives me what? This operates here on n, so this gives me n plus half h cut omega, and this is equal to En. If you compare this one, this gives me the eigenvalues for a one-dimensional harmonic oscillator. So one-dimensional harmonic oscillator, this is the eigenvalue equation. Okay, now let us find the talk about these operators. What are the eigenstate of these operators? Now suppose now I have a state, say a plus n, and now I operate my Hamiltonian on these states. So let us say what happens. My Hamiltonian is what? Hamiltonian is a bar a plus half h cut omega and you have a bar n. And now let us say if I take a bar common here, say if I take a bar a plus or a dagger common here, so this will give me what? This will give me a dagger plus half, and then you have this state n. Now we can easily prove that commutator of a and a dagger or a plus is equal to 1. So from here I can write that my a plus is equal to 1 plus a number operator. So I can now write here, I can write h cut omega, and this I can write as a 1 plus a plus half n. And this is the thing, this is the Hamiltonian h cut omega. when you operate on n, you get En. So this will become En, this En become, and you have a h cut omega state n. So this suggests that the state, this state a plus or a dagger n, when I operate h on n, I get the eigenvalue En. And when I operate my Hamiltonian on this state, my eigenvalue increased by h cut omega. That means this suggests that the operation of a dagger on n changes it to the next state, that is n plus 1 state. Similarly, I can also show when Hamiltonian operates on a n, my eigenvalues become n minus h cut omega. If I go similar way, n, that means that means somewhere when a operates on n, it reduces its indices to n minus 1. So it lowers the state. The operation of a plus increases the state by number by 1, while the operation of a on state n decreases its indices by 1. So this state goes to n minus 1, where this state goes to n plus 1. The operation of Hamiltonian suggests these things. Now what I can write, I can write now that my a plus is equal to, let us say Cn, when this operates on n, this gives me some value Cn, and the states goes to the n plus 1. Let us assume this one. Now these states are normalizable. Okay, all states are normalizable. So now if I take complex conjugate of this one, a plus n, if I take complex conjugate of this one, and here also I take complex conjugate, so what will become? This suggests me this become bracket is a cat, and now this become bra vector, and this a, we can show that a is equal to annihilation operator. So this become a, and now so this become a, and this become what? This become Cn star, and this also become bra vector. So here it was only cat vector, now it's become bra vector. That means this will become n plus 1, like this. So if I take now psi star psi, okay, if I take psi star psi, that is n a plus n. So this will become, I'm multiplying this to those sides, these two equations. So this become Cm mod of Cn square, and this become n plus 1, n plus 1. So this become Cn square. So I'm taking psi star psi, okay, psi star psi. So this becomes Cn square, and from here this is a number operator. So when number operator operates on n, it gives me simply n. That means my Cn value is, so this gives me what? If I sorry, now this is not number operator. Now if I write this one as a, say, n, now if I want to write a number operator, so this become a plus 1, and now this one. And now if you have solved this one, number operator on this one, so you get n plus 1. So this is my Cn mod square is equal to Cn, and Cn values I can take root n plus 1 because Cn is the norm, so we have to take only the uh, positive values. So this tells me that the operation of a dagger on state n gives me n plus 1 and states increases by 1. That means when a dagger operates on n, you can create a infinite sequence of states. If you repeatedly operate a on n, you can create n plus 1, n plus 2, n plus 3, like infinite sequence of states. Similarly, if I can prove that the operation of a annihilation operator on n gives me root n minus 1. It reduces my state by n minus 1. So you can create a repeated operation on a on n. You can create n minus 1, n minus 2, n minus 3 uh, states. So these two are the important results, and this operates on here. You get n plus 1 state, n plus 1. This operate here, you get root n minus 1. Now, in my next video, I will calculate the uh, eigenstate for harmonic oscillator. I'll stop here. Thank you very much.